Today, we're going to graph quadratics in Vertex form, and this formula is on your formula sheet that you have for Unit 1. It's also in the Google Classroom. And it is y equals a, and a is just a coefficient, so there'll be a number there, parentheses x minus h. H is a new player in the game. Parenthesis with a little 2 on the outside. And then plus k, which is another new player in the game. So this is called vertex form because it has the vertex embedded in the equation. So the vertex is already inside the equation. The vertex is, so there's no mystery or solving for vertex. The vertex is h comma k. So if it says, if your formula says like minus h, you're going to know what your h is already. So if you looked at this first one, because it's easier when you see an example, what would your h be in this first one since it's minus h, but the vertex is just h?
Well, it looks like we have 4 in that spot. In the formula, we have a minus, but in the other problem, we have a minus 4.
So the formula, just the letter h. Yep.
So just 4.
Yep. So h is just 4. If it helps, you can actually write h and k on here if it makes it easier for you. As we know from algebra 1, a, sometimes 2 negatives make a positive. So if you have a positive here, the formula says negative. So you got to think backwards. How would they have gotten to a positive? So that can happen. So like this first one is nice to start with because it starts with a minus just like the formula has. Some students will think about it this way and they'll look at the negative and they'll think like opposite of -4 is +4. And that helps some students. But if you're a formula person, like I think you and I are, it's a little bit better just to look at it like underline what h is in the equation that matches this. And you see how this has a -3. What's the formula usually have?
It looks like it usually has a plus. So that means we'll probably have -3.
Yes, so that means that whole thing is k. So that can be a little tricky for people. So just knowing if it's a plus, whatever's here, it is what it is. If it's a positive number here, that means k is positive. If it's a negative number here, that means k is negative. So we're gonna have our step 1 is to fill in our table and do our very first coordinate, which is always our vertex. And you guys already told me that it's a 4 for the first x or your h value. And your k, since it's negative and it's usually that plus sign, is your -3. So HK is just another name for your first X and your first Y in that table. Does that make sense? Okay. Can be a little tricky. So we want to pick our numbers that are close to 4. Do we have any preferences on our numbers?
We should go too big, but I'm looking at the graph.
It's okay if it goes off
either 3 and 2 or 5 and 6 if we have all those things, but maybe 3 and 2.
Yeah,
a little smaller.
Just know that Miss Amanda doesn't really care too much if you pick those bigger numbers and it goes off the graph. As long as your table is correct, you can draw a V-type shape with 2 points as well. Tricky question. Can we tell if this graph goes up or down just by looking at it since there's no negative in the very front?
So a negative usually goes down, but since this one's a positive, I'd say it probably goes up.
Yeah. And the A is kind of irrelevant. The A just stands for whatever coefficient is in front of the equation. There is some algebra 2 problems that solve for A. We don't do that in this course, but it is something that I'd be willing to go through.
Much.
Yeah, really doesn't. But they might be like, what's the leading coefficient? That'd be more of an Ivy Tech university kind of thing, but we'll keep it simple today. Not saying anything about you guys, just keep it to the point, you know, what do you really need? And if you do end up doing math classes at Ivy Tech, or you want to go to college somewhere, you're going to end up doing a lot of math stuff anyways to help get you ready. So we do the same thing we did last time, except we don't need to plug in the 4 because we already know the first coordinate is 4, -3, which we can go ahead and put 4, -3 on there. Does anyone know what our axis of symmetry would be based on our very first X value?
Is it 4?
Yep, so we can draw our dotted line through there. And now we only have to plug that 3 and that 2 in. So just like last time, we have an equation that helps us solve for y, right? There's nothing else on this paper, well, except for this, that says y equals. So we might as well use kind of like what we have to find y. So we're going to take the 3 and the 2, and we're going to input those in for our X value. I'll show you how you can do it in the calculator, but I can also talk us through how we would do it using PEMDAS. So you're plugging in the 3 and the 2 into the X spot. If you're using PEMDAS, PEMDAS tells us to do what's in parentheses first. So you would do 3 - 4, and whatever answer you get, you would square that. And then you would take away 3. So it'd be -1 squared, which is -1 times -1, +1, and 1 - 3. So do you guys want me to show the PEMDAS stuff? Sometimes it really confuses them, but I'm willing to do it. The PEMDAS would be like this. It's really not too bad, just like this, just the parentheses first, right? And then you want to keep those parentheses if you're, because you're squaring a negative, so it had to become positive.
Yes, I know that now.
So that would be, yeah, that would be your, if you want to do PEMDAS. A lot of the students will prefer to do this in their calculator. So you do parentheses, 3 take away 4, you want to use your minus button, squared, take away 3. So you don't want to use any negative unless there's an actual, you know, negative in the front. And it looks like we got the same answer. Yay, -2. Good job, PEMDAS people. And we can actually just use our little arrows, go back when it's flashing on our 3, since that's what we plugged in, and now we're plugging in a 2. We'll just pop our 2 in there instead. Oh, I changed it to a plus, my bad. Gotta go click on that and put a minus sign. There we go. So you shouldn't have to change anything but the very first number to get your second output. Does anybody want to see that using PEMDAS by chance? The second one?
I think the first time seeing it's good.
Okay.
Yeah. Just in case anybody wants the choice.
Just in case. Yeah. Usually if you've had like Math B or Algebra 1, you might do PEMDAS naturally and you'd be okay with it. I noticed some students who didn't have that foundational courses here, that PEMDAS can be an extra kind of barrier, but you are more than welcome to take that option. So we'll go to the 3 and then we'll go down 2 into the 2 and we'll go up 1. So this one is a little bit tricky because it hops over the X. There we go. And then we have to reflect it. So this dot right here is at the 3, and there's these little 2 boxes, or you could just think the difference between 3 and 4 is 1. So you'd hop over 1 away from the 4 to the 5. And then this goes from the 2 to the 4. So you got to go 2 spaces to the right from 4, or 2 numbers. I don't like how these graphs are spaced out, but you got to use what you got there. That does happen though. You want to look at the numbers. We're not going to do this in this class, but we do talk about x-intercepts sometimes when we get to Ivy Tech. And just knowing that when it hits this line right here, this x-axis, those are the intercepts. And you can guesstimate what it is. So it's really close to 6 and really close to 2.
Would we put it as a decimal or as a fraction if we were having to say what the x-intercept was?
It would kind of depend on your standardized test, what came up
I've seen
on
it both
there.
ways.
Yeah, you'd probably want to be prepared for either way. What you could do is if the multiple choice answers had fractions, is you could just divide them and see what they are as decimals and what's closest to those. And we call those points where it hits, which you don't really have to worry about this part if you're watching the recording. We call those solutions, roots, and x-intercepts. But it's good for people who might be thinking Ivy Tech after this. Yeah, very good. Good. And you can check it. It opens up, which is nice because there's an invisible +1 in the front. So that A value, you could even draw that little +1. It opens upward. Good. So let's do one that goes down. Would you rather do 2 or 4? Number 2 has an invisible 1, so they're kind of the same, but
We do the one with like the
bigger number? With a number, yeah, I agree. I was kind of hoping you would say that. Good. So for number 4, it also has a positive, which is good. So I'm going to rewrite my formula. You guys don't have to. You can look at your formula sheet if you'd like. So the original template for Vertex form has a -h. So in this case, you got to be a backwards thinker, okay? So if it says -h, but in parentheses, it has a +2, that really symbolizes a minus a -2 because the original template had a minus. So what would your h have to be instead of +2?
Looks like it'll have to be -2. So negative.
Yeah, very good. So h should be -2. The good news about k is k always stays the same. So that is kind of nice. And these ones are nice because you already have your vertex. So once you have that h and k, you can just pop that in as your first coordinate in your table. That's a 4, not a y, by the way. Just a little messy. So we can go to the -2 and we can go up 4 and put our dot. We can also draw our vertical line through our first x value, since that's always going to be our axis of symmetry, or AOS. So we want two numbers that are close to -2. Would you guys rather go more towards 0 or this way on the number line to the left? You can also look at the numbers on the X.
I'd rather go to -1 and 0 because they're
Okay.
a little bit,
Yeah.
simpler numbers in a way.
Yeah, you can go that way. Sometimes I feel like some students really have to count and the negatives and that stuff throws them off. So they'll be like 2, 3, 4. And so it's easier for them to pick those numbers. It does not matter which ones you pick as long as they're
You're getting the
close.
same thing.
Yep, you're gonna get the same thing, just on the opposite side of the graph. Good. So where are those -1 and the 0 going to get plugged into? This y equals or this y equals on the left?
Or one with your numbers, because now we're trying to find y is equal to.
Mhm.
So
Yeah,
we're going to use the one that says y is equal to.
you got it. Very good. A lot of times people will be like, wait, I can't do anything else. And I'm like, well, if you're trying to find y, there's an equation and it's right
Using the
there.
number for x,
Yeah, and I'm like, you have an x value, so you can just take those one at a time and plug them in. And usually I only show it once, but if you're a person that needs to see it twice, you could write it out 2 times with the -1 and the 0. But just remember, you don't really have to show this step. Some people just prefer to do this right in there. So this whole thing can go in your calculator. I know some of you guys like PEMDAS, so I can show it using PEMDAS if you'd like on this top one or bottom one. I think I could squeeze it on there. You like to see?
Maybe the bottom one.
Maybe the bottom one, a little more rim. So 0 + 2 would be our parentheses. So we'd do that first. So that would be 2 squared. Anybody know what 2 squared is?
It's a 4.
Yes, very good. And drop my multiplication down. I always run out of room when I do PEMDAS. That's another reason I don't do it a lot. So -2 times 4 is -8. And then add 4 to that. And that will be, just draw a little arrow, -4, which we could check that in our calculator as well. So we'll go ahead and enter this one in our calculator and then this one and make sure we get that -4 for the second one. Yeah. I'm glad you asked about that. I usually, based on how many times I've done it, I assume that people don't like it. I don't know why. PEMDAS can be a challenge sometimes. But I remember it was also kind of difficult for me in like 6th grade when we were learning PEMDAS. I was like, I don't think I like
I feel like
this.
for PEMDAS, I like to use it because that's the one thing I'm like, I know the order well.
Yeah, see, you're good. A lot of times with the exponents, like that'll be an easy little mistake for people to mess up. Like, do I do multiplication first or do I do exponents? I'm like, well, it's PE, you know, and M and D can go either way, well, left to right. But yeah, I definitely understand. So just to make sure that -4 comes out right, I'm going to go ahead and plug in my 0. And make sure we get beautiful. It worked. Very good. Yay, we got the same thing. So we can go -1, 2, and 0 is right at that point where they meet, and then just go down 4. Anyone notice anything a little bit different about this graph in terms of its structure? I can put the whole graph on there for us too, after we
It
reflect
looks
it.
different as far as it's the negative, so it's going down instead of up.
Yep, so it's going down because it's negative. We can write that on there. And it's also a little bit on the slender, narrow side of the graph.
Oh, yeah, it is.
So that the bigger that number in front, the more slender, more narrow your graph will be. And sometimes you miss the mark and the dot just doesn't connect with the line. And as long as your table is accurate and your dots are on there, we'll call it good. If it's not perfect. If you wanted to approximate where the x-intercepts are, you can kind of see they're around this general area between 4 and 3 and between -1 and 0. That just wasn't on our unit exams or finals, so I did cut that out for you guys right now at this point. But if you want to do x-intercepts for extra credit, go for it. Wonderful. Well, I hope you feel more confident on Vertex form today.
I do. Very much.
Very good. Very good. Wonderful. Have a nice day, everyone.
Thank you.